If we are given that 9x plus 4y plus z is equal to 128, then what is the maximum value of 9 root x plus 8 root y plus 5 root z, where x, y, and z are positive real numbers? So looking at the problem, we can see that these terms over here are pretty similar to the squares of these terms over here. So that gives us the intuition to use Cauchy-Schwarz inequality. The Cauchy-Schwarz inequality states that for any two sets of real numbers, a1, a2 all the way to an, and b1, b2 all the way to bn, the following inequality is true. So a1 squared plus a2 squared all the way to an squared multiplied by b1 squared plus b2 squared all the way to bn squared is greater than or equal to a1 times b1 plus a2 times b2 all the way to an times bn, all of it squared. So we notice that the coefficients before all of these terms, being 9, 4, and 1, are all perfect squares. So 9x is equal to 3 root x all squared, 4y is equal to 2 root y all squared, and z is equal to root z all squared. That lets us use 3 root x, 2 root y, and root z as our first set. So our first set is going to be 3 root x, 2 root y, and root z. So for our second set, we want to find terms such that this term multiplied by a number would be equal to this term multiplied by a number will be equal to this, and this term multiplied by another number would be equal to that. That way, we can find 9 root x, 8 root y, and 5 root z on the other side of the inequality. So 3 times 3 is 9, so we want our first term to be 3. 2 times 4 is equal to 8, so over here we have 4. And 1 times 5 is of course equal to 5. So the last term for our second set is going to be 5. Alright, so now let's plug these values into the Cauchy-Schwarz inequality. So over here we have 3 root x squared, which is 9x, plus 2 root y squared, which is 4y, plus root z squared, which is equal to z, multiplied by 3 squared plus 4 squared plus 5 squared, which is 9 plus 16 plus 25, is greater than or equal to 3 root x times 3, which is 9 root x, plus 2 root y times 4, which is 8 root y, and root z times 5, which is 5 root z. And all of this is squared. So it is given to us that 9x plus 4y plus z is 128. So we have 128. And we know that 9 plus 16 is 25, and 25 plus 25 is 50. So we have 128 times 50 is greater than or equal to 9 root x plus 8 root y plus 5 root z all squared. Now 128 times 50 is equal to 64 times 100, which is 6400, which is of course 80 squared. So we have that 80 squared is greater than or equal to 9 root x plus 8 root y plus 5 root z all squared. And because and only because this has to be positive, we can cancel out the squares on both sides. So we have 80 is greater than or equal to 9 root x plus 8 root y plus 5 root z. So we have found the upper bound of this expression, but we have not shown that equality is possible. So now we're going to use the Cauchy-Schwarz equality case to find the values of x, y, and z such that this expression is equal to 80. Alright, so equality is reached when 3 root x, 2 root y, and root z is a scalar multiple of the vector 3, 4, 5. In other words, 3 root x, 2 root y, and root z come in the ratio 3, 4, and 5, and it satisfies 9 root x plus 8 root y plus 5 root z is equal to 80. So using this information, let's solve for x first, and then y, and then z. So obviously 9 root x is equal to 3 root x times 3, so we have 3 times 3 root x. And then we know that 2 root y is equal to 4 over 3 times 3 root x. And then 8 root y is 4 times that, so we have 4 times 4 over 3 times 3 root x. And then applying the same logic to z, we have 5 times 5 over 3 times 3 root x. All this is equal to 80. Now, this is equal to 9 root x, this is equal to 16 root x, this is equal to 25 root x. So we know that 50 root x is equal to 80, and x is equal to 80 over 50, all squared, which is equal to 64 over 25. Now, applying the same logic to y, we have that 3 times 3 over 4 times 2 root y plus 4 times 2 root y plus 5 times 5 over 4 times 2 root y is equal to 80. Now, this is equal to 9 over 2, this is equal to 8, and this is equal to 25 over 2. So we have that 17 plus 8, or 25 root y, is equal to 80. So 25 root y is equal to 80, and y is equal to 256 over 25. Now, plugging in these values of x and y into this and setting it to be equal to 80 shows us that z is equal to 64. So z is 64. And so now we've shown that there are values of x, y, and z that exist such that this is equal to 80, and we've shown that the value of this expression cannot be greater than 80. Therefore, the maxima of this expression is equal to 80. So this is lesser than or equal to 80. And that is our answer, and we are done. All right, thanks for watching. Hopefully you enjoyed, and hopefully I'll see you next time.